Hi guys! My name is Sandra and today we will unbox, assemble, test and review the HURAKAN 3D printer from Biqu. So if you want to know all about this 3D printer, including the pros and cons, do like Maggie and stay with us until the end of the video.
Hi guys, welcome back. My name is Rui and this is the Rui Raptor YouTube channel. If you want to help us out, you can by giving this video a like and subscribe to the channel. You can also help by joining our Patreon page or by clicking on any of the affiliate links posted below in the video description.
So, as we mentioned in the intro, we have the HURAKAN 3D printer from Biqu. This printer comes with Klipper installed from stock and includes a few interesting features. We will show you all that, but first let's start with the unboxing. The first things we see is a small filament sample, a bag with accessories, a LAN cable and a power cord, the traditional BIGTREETECH rubber duck, the accelerometer sensor, a PTFE tube, the display, the parts for the spool holder, next we have a small user manual, the top off of the printer, the X-axis, and finally the base of the printer. And this is everything that came inside the box.
This is the base. The print surface has a small amount of texture and it's a steel magnetic plate. At the front is the micro SD card slot for the Klipper operating system and the SD card slot for the board. The Y-axis is equipped with the belt tensioner here. Here at the side are the flat cables that will connect to the display. On the other side are some more cables that we need to connect later on. There's also the main input power connector and the on and off switch. The vertical profiles from the top half will be attached here. The heat bed cable is attached to the bed to this piece, which has a button and a couple of LEDs that we will explain in a few minutes. At the back, there are a couple of USB connectors, one LAN connector, and an SPI connector. There is also an opening to check the main input voltage selector. To check the electronics, we need to turn the base upside down and remove all these screws to open up the cover plate. Attached to the panel is a small fan, so be careful when removing it. On the inside of the plate, we can find the board's layout printed on it. This is a nice detail that BIGTREETECH has implemented on most of their printers. Inside, we can find the BIGTREETECH's Manta M4P board equipped with the CB1 module. We have already talked about this board on the previous video, so if you want to see all the details of this, check the video description below for the link. The drivers installed are 4 TMC's 2209 drivers, also from BIGTREETECH. There's a USB and LAN extension cables connected from the board to the back of the printer. One small detail that is not as good is the connections to the screw type connectors. Most of the wires connected to them are not crimped, which is a negative point. The power supply on this one is a 24 volts and 14.5 amps output model. Because the power supply is not side by side with the back frame of the printer, BIGTREETECH made a see-through area on the frame so the user can check the power supply's main input voltage selector. On our printer, the stepper motor cable was kind of in the way, so it would be better if the manufacturer would arrange this better so the user could see clearly the selector. And this is the top half of the printer. The profiles are smooth on the side that is facing the user. At the back, there's the Z stepper motor and the lead screw that came with the protective cover. The corners are cut in an angle and covered with these plastic pieces. And this is the X gantry. There's a belt tensioner on the X axis as well. The print head has an original design and equipped with a couple of layer cooling fans, one on each side. In front of the nozzle is the new touch sensor from BIGTREETECH. The print head is also equipped with RGB LEDs to light up the print area. At the back, we have the X and extruder stepper motors, the extruder and filament runout sensor. The extruder is all metal and dual gear, which is very nice. The display is this one, and it's controlled by this rotating knob. At the back are the two connectors that will need to be connected. Also with the printer is this small sensor and cable. This is the ADXL 345 accelerometer sensor that will be used to calibrate the input shaping feature, but for this, we will talk in more detail later on. Okay, now for the assembly. And for the first step, remove the Z-axis stepper motor from the vertical profile. Next, align the top half and the X gantry on the table like this, with this side of the profiles facing up. Then, take the X gantry and slide it on the vertical profiles like this. If the wheel's grip is too tight, don't force it. Instead, take the small wrench and turn the eccentric nuts to increase the wheel's distance between each other, and then try again. If you want to know more about how these eccentric nuts work, check our other video. With the gantry installed, take the Z stepper motor again, remove the protective cover, and install it back to the vertical profile. You need to turn the lead screw so it can go in the lead screw nut. Do this until the motor aligns itself with the holes on the profile, and tighten the two screws. For the next step, you need the long M5x40 screws. You will need them to secure the top half to the base. So, take the top half and align it with the holes on the base, making sure that the print head is facing the front. Take the screws and tighten them, 2 on each side. Before moving on to the next step, make sure everything is correctly set and squared. Also, make sure that the vertical profiles have the same distance at the bottom and at the top. Now, take the display and the M5x8 screws. Connect the two cables to the display first. They are marked with labels, so connect them at the correct position. And then, secure it with the two screws. Now for the connections. All the wires are labeled, so make sure you check everything. The flat cable is connected to the print head. Make sure the flat cable passes under the top horizontal profile. Connect the cable and lock it with the two side latches. Then connect the Z stepper motor. The X-axis and stop switch, and the X-axis stepper motor, the filament runout sensor, and the extruder stepper motor. Next, screw in the fitting to the extruder and attach the PTFE tube to it. The other end of the tube, attach it to the print head. Make sure you insert it all the way in. To protect the flat cable, use a zip tie to secure it to the carriage. On our case, the heatbed cable was bent to the right, causing it to get caught by the Y-axis, and this way keeping the bed from moving all the way to the front. To prevent this, we used a zip tie to keep the heatbed wire away from the Y-axis and close to the other cable instead. With the cable secured this way, the bed now moves freely all the way to the front. Now it's the spool holder. To assemble it, pass the metal piece on the cylinder first, and then lock the ring on it like this. Place the screws and T-nuts on the metal piece like this, and then install it at the top of the printer. And the assembly is now complete. The print volume of this printer is 220 by 220 by 270 millimeters. And this is how the printer looks like when assembled. Before we can turn the printer on and make the first tests, we need to make a few checks and adjustments. First is the X and Y axis belt tension adjustments. These can be done by turning the knob for each one. For each carriage, we also need to adjust the wheel's grip. There are a couple of them on the Y-axis carriage at the left side. There's also one on the bottom wheel of the X-axis carriage, and a couple of them on the Z carriages, one on each side. We made a video explaining this procedure in detail, so check this video for more details. Okay, we can now connect the power cord, but make sure you have the microSD card inserted before turning the power on. This memory card contains the operating system, and without it, the printer will not work. On the display, we can see that it's loading and will take a few seconds to start. Once it's ready, we have the nozzle and heat bed temperature on the screen, the fan speed, the feed rate, the printing percentage and time, and the status. If we click on the knob, we enter the menus. And at the bottom of the menus, we have the IP information, which is available because we have already set up the Wi-Fi connection, and the command to shut down the printer. This last one is recommended to use before turning the power off to prevent corruption of the micro SD card. In the SD card menu, we have access to the print files. This printer comes with some already compiled files that we can use to test. In Control, we can home all the axes, run the manual level of the bed, execute the bed mesh and store it, deploy the probe from the leveling sensor, retract the probe, home the Z-axis, home just the X and Y axis, turn the stepper motors off, turn the fan on and off, set the fan speed, and move the axis in 10mm steps, 1mm steps, or 0.1mm steps. In temperature, we can control the extruder and heat bed temperatures, preheat for PLA, preheat for ABS, and turn the heaters off. In filament, we can load the filament with fast and slow speeds and unload with fast and slow speeds as well, and the feed value. In setup, we can save the config, restart, run the PID tuning, run the calibration for the Z offset, and finally dump the parameters. In LED control, we can control the LCD and hot end lights. The LEDs are RGB, which means we can choose between white, red, green, and blue. As we mentioned before, the print surface is this magnetic steel sheet. One thing we noticed is that the magnet is not very strong at the corners and might lift and warp the prints that reach the corners of the surface. The heat bed has no alignment pins to help position the print surface in the correct place. Without them, it's very easy to get the print surface misaligned. The heat bed has two heating elements, one located under this center square and another for the remaining area. This means we can heat up just the center of the bed or the entire bed. At the back, there's a switch that controls this. The red LED lights up when the bed heats up, and with the switch turned off, only the heating element at the center is being used. With the switch at the on position, the blue LED lights up and both heating elements are being used. With just the middle one, we have a consumption of 100 watts, and with both, we have a consumption of 240 watts. When we analyze the heat distribution with only one heater turned on, we can clearly see that the heat is located within the inner square marked on the print sheet. With both heaters turned on, the heat spreads out through the entire build plate. Before running the first print, we need to level the bed. The option to level the bed will allow the nozzle to move to each corner automatically, so we can adjust the bed with a 0.1 mm thick piece of paper and the leveling knobs. Do the same procedure for all 4 corners and as many times as needed until all 4 corners are leveled. If you want to learn more about this procedure, you can check the first half of our video about bed leveling. You can check the link below in the video description. Next, we can run the auto level sequence. This will probe the bed 25 times and save the mesh. As we mentioned before, the leveling sensor on this one is the new micro probe from BIGTREETECH. This sensor is rated as super lightweight, durable, and high precision. Last but not least is the Z offset. We can check and adjust the Z offset by entering this setup, then calibration, and then start probing. The machine will probe the bed and stop at the center. Next, you move the Z carefully until the nozzle is close to the print surface. And then use the test Z and small increments to adjust the nozzle height. The distance between the nozzle and the bed should be 0.1 mm, the same as the piece of paper we used to level the bed. When done, go to Accept and Save. You will see the display reboot, and that's it. For the Wi-Fi to work, we need to turn the printer off and insert a memory card on the computer and open this file with Notepad++. Inside, we need to enter our Wi-Fi SSID and password here. With the memory card back on the printer, we can turn the printer back on and check the IP address on the display. We entered that IP on an internet browser and we are now connected to the printer. Okay, we are now ready for the first tests. And for the first prints, we decided to go with the already sliced models that are available on the memory card. The first one prints these lines. This is meant to test the leveling of the bed. At the end, we can check the results and adjust the Z offset if we need to. On our case, the Z offset was a bit high and caused these lines to lift from the bed. Next was a kind of small tower. And then an enlarged version of the benchy. For the next test, we ran the vibration test model. Once that was done, we installed the accelerometer sensor on the side of the print head, and the cable connected from the sensor to the SPI connector at the back of the printer. The commands are very easy. Just type G28 to home all the axes, and then shaper_calibrate space axis equal X, and enter. With this command, the machine will start the calibration for the X axis. It will take some time to finish, and when done, we need to store the results by typing save_config or clicking on the save config at the top of the screen. That's it for the X axis. For the Y axis, we need to print this small piece and attach the sensor with it on the back of the heat bed. The commands for the Y axis are the same, but instead of the X, we type in Y. If we take a closer look at the printed models before and after the calibration, we can clearly see that this reduces the ghosting issues and will allow you to print a little bit faster. Next, we decided to print some models with our own profile. We sliced the model and saved the G-code on the computer. Then, we entered Klipper by typing the printer's IP address on an internet browser. Here, we click on Upload and Print and select the file. For the first test, we printed the traditional ripple cube. Next, we printed this cool minion. We also printed this nice bowl. And also this detailed vase. We also tested the pause feature running the M600 command on the G-code and worked as expected. All these prints were made with PLA filament. We also tested printing this tire with TPU filament. When analyzing the test prints, this is what we got. With the already sliced models and for the vertical tube, we see very nice layers. The model has these vertical lines all the way from the bottom to the top, but most certainly are from the original model. As for the oversized benchy, it turned out okay. Again, smooth layers and no issues with the overhangs. The only thing we noticed are these horizontal lines located far apart from each other. The test with the ripple cube shows a very good result, as you can see. The minion also turned out very nice. Again, very smooth walls, and it captured all the details nicely. Same result with the detailed vase. We found no issues here as well. In the bowl, it turned out very cute. Finally, the tire made with TPU filament also turned out okay. We found no issues while printing with flexible filament. Okay, now for all the pros and cons. And for the positive side, we have the assembly. This machine is very easy to assemble and it takes just a few minutes to get it ready to run. The user manual, which has clear instructions on how to set up the printer and how to run the calibrations. It's equipped with a Manta M4P board and CB1 module, a filament runout sensor, BIGTREETECH leveling sensor, which is very nice, belt tensioners for the X and Y axis, Capricorn tube, dual gear and all metal extruder, and also the accelerometer sensor for the vibration calibrations. It has a couple of layer cooling fans, one on each side. The heatbed has dual heating zones, and the print surface is a flexible magnetic plate, which has very good adhesion when hot and releases the prints easily when cold. The printer is very silent when printing. Not only the stepper motors run silent thanks to the TMC's 2209 drivers, but also all the cooling fans are very silent as well. Comes with Klipper installed and ready to use from stock. The display and menus are user-friendly. Also, the information of the IP address on the screen is very nice to have. It has good printing quality. As we have seen from the test prints, this printer can output good prints, especially after the vibration calibration with the accelerometer sensor. And for the negative side, we have the startup time. It takes some time to start up since it has to load the operating system from the memory card. Also, since the operating system is on the memory card, the printer will not work if the card is missing or damaged. We recommend to create a backup of the card as soon as possible. The print volume is a bit small. It would be nicer if the print volume was a little bit bigger. It has no alignment pins to help position the print surface in the correct place. The magnets are not as strong at the corners, and this might cause warping on the prints that are next to the corners of the bed. The heatbed cable arrangement. As we have shown, the heatbed cable was getting caught by the Y-axis, which prevented it from reaching the full travel. Probably not all the printers will have the same issue as ours did, but it would be nice if the manufacturer would consider this and arrange the cable differently to prevent this from happening. And finally, it has no print resume feature. And these are all the pros and cons of this printer. And that's it, you guys. Hope this video was useful. We will see you guys next time. Bye!